In this program, we will look at some basic engine technology as it applies to Cummins high-horsepower lean-burn natural gas engines. We will also discuss the fuel and its safe handling. The Otto cycle is the four-stroke cycle that is commonly used in the internal combustion engine. The cycle starts with the downward motion of the piston drawing fuel and air into the cylinder past the open intake valve. As the piston rounds bottom dead center, the intake valve closes and the trapped mixture of fuel and air is compressed by the upward movement of the piston. As the piston nears top dead center, the spark plug ignites the compressed gases. The burning fuel-air mixture expands rapidly, driving the piston down and creating power. As the piston again nears bottom dead center, the exhaust valve opens and the burnt gases are pushed out of the cylinder by the upward movement of the piston. As the piston again rounds top dead center, the exhaust valve closes and the intake valve opens. Another intake stroke begins and the cycle repeats. When the fuel in the cylinder is mixed with just enough air to completely oxidize the hydrogen and carbon, the air-fuel mixture is said to be stoichiometrically correct. In other words, the stoichiometrically correct mixture is the chemically perfect balance of air and fuel for complete combustion. When an excess of air is present in the cylinder, the mixture is lean. When a lean mixture is delivered to the cylinder, there will be oxygen present in the exhaust. An excess of fuel in the cylinder is referred to as a rich mixture. When a rich mixture is burned, the oxidation of the fuel will be incomplete. This shows up initially as carbon monoxide, CO, in the engine's exhaust. The Cummins high-horsepower lean-burn natural gas engines are designed to run at a lambda greater than 1. This provides for very low emissions since the excess air flowing through the cylinders carries off heat and excess heat is the major cause of oxides of nitrogen, mostly NO and NO2 emissions in the engine. For controlled combustion, the spark plug ignites the fuel and the flame front sweeps across the cylinder at subsonic speed. This gives a steady push on the piston and efficient power production. Abnormal combustion, called knock, is caused when the fuel octane rating, a measure of the fuel's resistance to knocking, is insufficient for the pressure and temperature present in the cylinder. When knock occurs, spontaneous combustion takes place in the cylinder, creating multiple flame fronts that travel at supersonic speed. Combustion is uncontrolled, and the collision of these flame fronts cause the characteristic knocking sound. Since methane is lighter than air, it tends to dissipate naturally. Methane gas detectors, when used to check for leaks, should always be held above the fitting being tested to improve response and ensure the methane is detected. A specially prepared soap and water solution may also be useful for pinpointing leaks. Always use the proprietary solution required to meet regulations.